All right, let's go through a real basic example. Let's say I want to calculate the design shear capacity of a beam. Let's say the beam's 12 inches wide and it has number 3 U-shaped stirrup. We'll say spaced at 6 inches. Concrete strength is 4 KSI. Yield strength, steel 60 KSI. We'll say by effective depth, D 20 inches. And our job here in this example will be to find the design shear capacity of this beam. Okay? All right, what I would do in this is we'll just sort of roll it out, you know, based on the formulas that we previously talked about. Phi Vn is really equal to phi Vn is equal to the sum of V sub c plus V sub s. You know that phi, when we're talking about shear, the strength reduction factor, when we're talking about shear, is always 0.75. So let's calculate V sub c. 2 square root of 4,000. Again, make sure that concrete's compressive strength is expressed in PSI, you know. And the square root only goes over F prime C. The width of the beam, we said, was 12 inches. The depth of the beam, we said, was 20 inches. So 2 times square root of 4,000 times 12 times 20. What do we come up with?
3,357.87.
30,000?
Yeah.
357?
357.87.
Okay.
Yeah.
We'll say 30,358 pounds.
Mm-hmm.
Okay? Now, if you want to put that into kips, I usually like working in kips. If you want to, you know, put that in kips, then just divide by 1,000. But do it at the end. Don't try to do it up here because that'll mess everything up. All right? So 30,358 pounds or 30.358 kips or 30.36 kips. However you want to express it. Okay, next piece. V sub s. V sub s is AV Fy times D divided by S. AV, I'm using number 3 U-shaped stirrups. So what's the area of a number 3 bar? 0.11. What is my AV for a number 3 U-shaped stirrup? 0.22. It's 2 times 0.11 because I've got 2 legs. A U-shaped stirrup has 2 legs. Those 2 legs are going to be the pieces of steel that intercept the crack. Times 60. Now again, if I'm using pounds up here, then I'll keep this as 60,000. If I want to use kips, I'm going to use 60 KSI, but it's, you know, again, it's whatever your preference is. D is 20 inches. And the spacing that I'm interested in, or the example problem has, is what? 6.
44,000.
34,000?
44.
44,000. Okay, and again, if you were working in kips, that'd be 44 kips. I mean, that's fine. Either way you want to do that. So, what is my design shear capacity? Phi is 0.75. V sub C, 30,358. V sub S, 44,000. So my design shear capacity is what?
74,357.
Wrong.
55.
55,
77.
770.
706.68. Yeah, lady.
55,770 pounds. Remember, I'm asking what design capacity is. You got to multiply that by the reduction factor out here. Okay? So this example, my shear capacity of this beam, when I'm using this 6-inch, this type of stirrup at a 6-inch spacing, you know, this size of beam comes up to 55,770 pounds.